This example is the typical speed distance time example. So if you still remember Sec 1, we encounter speed distance time. So when it is a speed distance time, we'll start to draw the triangle. And when it is speed distance time, you actually got to take note of the units. So some of you keep making mistake in speed distance time because to you, right, you don't really pay attention to the units. Okay, so my reminder again, pay attention to the units. If you don't pay attention, most probably you cannot show certain equation. Okay, so let's try to understand the question first. So two towns are 280 kilometers apart. So essentially this one is the distance. And then Andrew drove from town A to B at a speed of this. So this is the speed. Okay, so look at the distance, it's 280 kilometers. The speed is kilometer per hour. So the kilometer is matching already. Okay, so with this, right, I can do my part A. So if I would like to find the time, and the time is in hours, from A to B, I got to apply the formula. So according to the triangle formula, if you would like to get the time, it's distance over speed. So you must make sure the units match. So it's kilometer and it is X kilometer per hour. So the time is this in hours. Okay. Now on the return journey, okay, let's take a look on the return journey. So when it is the return journey, any changes? So obviously, if you are doing the return journey, the distance is still 280 kilometers. The distance doesn't change. A to B, B to A is still the same distance. But then, right, the speed increase. So instead of the original speed, it is actually X plus 10. Okay, so they say the average speed is increased by 10 kilometers per hour. So what about the time taken for the return journey? Return journey means B to A. So it will still be the same formula, distance over speed. The distance doesn't change. Okay, the speed is the X plus 10. And realize the units match, kilometer and kilometer, and it is in hours. So that will be 280 over X plus 10. So that is the amount of hours for the return. Okay, here comes the challenging part. They gave you a piece of information. The difference between the two journeys is 30 minutes. And your job is to show that you will come to this quadratic equation. And your job is to show that you will come to this quadratic equation. And when we talk about the difference is always the longer journey subtracting the shorter journey. So if you think, you got to use a bit of common sense, or you got to think a little bit, which one take a shorter time and which one take a longer time. Okay, so how should your thinking process like? Okay, so this one, the speed become faster. Because the speed become faster, this one will take a shorter time than this. Okay, so you increase the speed, that means you will take a shorter time because your speed is faster. So you will take a shorter time. Okay, so in order to try to show the equation, I should take the longer timing to minus the shorter timing. Okay, take the one that is longer, the longer journey. So the longer journey is the A to B. Okay, the shorter journey will be B to A. It takes a shorter amount of time because the speed is faster. Okay, so we will need to do this. Okay, whoever don't pay attention to the unit, they will do this. And then they will try to prove. Okay, so no matter what you do, if you have this part like this, you will not get the equation because the units doesn't match. Okay, the units doesn't match. Why does it not match? Because this is in hours. This is also in hours. So if the quantity is in hour, how many hours? I cannot be using 30 minutes. I got to convert the 30 minutes to hour, which is half an hour. Okay, so here, this is the equation. So how will the equation be reduced to this part? So this is the challenging one. So this will involve some idea of fraction algebra, which actually you learned it in Sec 1, but you are going to do it in Sec 2 again. So in this case, it will be fraction minus fraction. So whenever it is fraction minus fraction or fraction plus fraction, you got to make same denominator. So this one you have done it last year. Actually, it shouldn't be too new to you. But some of you are still very hindered when you see fraction. So in this case, I'm going to make same denominator. So I multiply x plus 10 to the first one. I multiply x to the second fraction. And that is half an hour. So my usual approach is, after I got same denominator, I make it into a single fraction. I make it into a single fraction, and then I go for cross multiply. Some of you are doing it a different way. I leave it up to you. If your method will always ensure you got the correct answer, I'm fine. Or else you go for this method. Make same denominator and you cross multiply. Okay, make same denominator, then cross multiply. Okay, no. Same denominator already, then you got a single fraction. Then you cross multiply. This is not something new. You did it in Sec 1. Okay, so I'm going to do my expansion in the numerator. Okay, I'm going to do a bit mental. So if I do that, I get this. And then I will get x squared plus 10x. Then I will do my cross multiplication. So I will do my cross multiplication. Okay. And that's how I got the equation. So look carefully that you got the equation. So when you got the equation, you just write a shown. Okay, look super carefully. This is a plus and then this is a minus. So make sure you get the plus 10 and minus 5,006. Some students, right? Let's take a look. Some students, they may get this. Okay, listen up. Some students, they will get this. And usually when they get this, they get no marks. So when you get this, right, that means you subtract wrongly. So when you get this, there's a different sign from the equation. That means you subtract wrongly. You use the short one to minus the long one. Okay, so don't think that I got the same number, but my sign is different. So does that matter? Yes, it matters. If you get a different sign but same number as the equation, you actually get no marks. That means everything is wrong. Okay, so strictly you must get to their equation. But some students, right, they can be so blur, they can be so unaware. They didn't even know that they didn't get the same equation. Okay, so please bring up your level of awareness. All of you are Sec 2 already. It's not like you are Sec 1. Okay, so part C is the hardest. You got to do a lot to get to the equation. The last part, I will need to do the solving. And after the solving, I must find the total amount of time Andrew spent traveling. That means I must find the amount of time he takes from A to B and B to A. Okay, so do your usual solving first. Okay, I hope I have enough space here. So do your usual solving. Okay, can mentor this thing. So if I do my usual solving, okay, I will get 2 answers. And X being the speed, the condition will be, it must be positive. So since it must be positive, then it will be 70. I cannot be accepting the negative 80 because it doesn't make sense that the speed is minus 80 kilometers per hour. So from here, what is the total time? The total time will be the timing from A to B, which is this one, and B to A. So what you can do is you write the algebra first, and then you can put in the 70. So when you put in the 70, here you got the 4 hours. Here you get 3.5 hours. So in total, that will be 7.5 hours. Okay, so how many marks will this kind of question cost? It can range from 8 to 10 marks, depends. And this is the type of question that you are going to see next year. In Sec 3, you're going to see this type. Proving is around the same. Solving, we'll use a shortcut to solve. And in the O-level exam, right, there will be one question every year. So in fact, I can throw you an O-level question. I can throw you an O-level question and you can try. Okay, so right now you got to build from the simpler one. Just now I show example 8 and 9. So this one is the longer one. Okay, so this question involves a little bit of fraction. So you need the idea of fraction plus fraction and fraction minus fraction. Okay, so later on I'll be showing you a bit more on this type where you involve fraction in the fraction algebra part.